You ever just look up at the night sky and feel, well, completely awestruck? Today, we're going to try and bridge that vast cosmic distance. I'm going to show you how you can actually measure a piece of the universe right from your own backyard with a tool that's been around for literally centuries. So let's dive in. All right, so let's start with a really big question. You know the northern lights? Those incredible shimmering curtains of light, the aurora borealis? They just look otherworldly, right? Almost impossible to touch. But how high up are they? Like, for real? Could you even measure something like that from way down here on the ground? I mean, that sounds like a job for satellites and some pretty advanced tech, doesn't it? Well, get this. Back in the 1920s, a Norwegian astrophysicist named Carl Sturmer, he figured it out. And he didn't have supercomputers or anything like that. Nope. He used a principle you probably learned back in middle school. Just simple geometry. And the answer he came up with? It's just staggering. The aurora, it turns out, usually dances somewhere between 90 and 130 kilometers above our heads. That's up to 81 miles high. And he figured out that massive distance using an ancient tool and some really clever math. And that's exactly the method we're going to explore right now.
Okay, so what was this incredible tool that could connect the centuries like that? Well, it's the hero of our story today, the ancient astrolabe. It was basically a key that helped unlock the cosmos.
So an astrolabe, at its very core, is just a tool for measuring angles. To be specific, it measures the altitude, the height in the sky, of things like stars and planets. But as we're about to find out, you can use it for a lot more than just stars.
And what's just incredible is how long this invention has been around. The astrolabe was invented way back, around 200 BC. And for centuries, I mean centuries, astronomers and navigators were using it to figure out their latitude, tell the time, track the stars, you name it. That beautiful one you see there, the Canterbury astrolabe, that's from 1388. And then fast forward all the way to the 1920s, and Carl Sturmer is using the same basic principles to measure the aurora. That's over 2,000 years of discovery from one core idea. Just amazing.
Okay, and this is where it gets really, really cool. You don't have to be some ancient navigator or a famous astrophysicist to use one of these. We're going to take this historic artifact and turn it into a simple DIY project. Let's get into how you can build your very own. And you know what the best part is? You probably have almost all this stuff lying around your house right now. You just need a template you can print out, some scissors, tape, a bit of string, a paper clip, a straw, and, some markers or colored pencils to make it look cool. That's literally it. All right, so putting this thing together is incredibly easy. First up, just cut out the template. Simple enough. Next, grab about 25 centimeters of string and tie a paper clip onto one end. That's going to be your weight to keep the string hanging straight down. Then just poke a little hole in the corner of the template where it shows you and tie the other end of the string right through it. Okay, to finish it off, just tape a drinking straw right along that top straight edge. That's going to be your viewfinder. And last but not least, the fun part? Go ahead and decorate it. Make it totally yours. Just one thing, be really careful not to color over those super important angle markings along the curved part. And that's it. You've literally just built a scientific instrument.
All right, you've got your astrolabe. You've built your tool. Now it's time to be a field scientist. Let's take this thing outside and actually put it to the test.
Okay, so the process is really simple. First, just pick something tall to measure. Could be a tree, a flagpole, the side of a building, whatever. Second, you need to measure the distance from where you are to the bottom of that object. Go ahead and write that number down. That's your baseline. Third, you're going to want to get low to the ground, hold up your astrolabe, and look through that straw, tilting it up until the very top of the object is in your sights. And finally, and this is the key, let that weighted string just hang perfectly straight and see what number it's pointing to on the angle markings. That right there, that's your viewing angle. And just like that, you have the only two numbers you need. Okay, so you've collected your data. You've got a baseline distance and a viewing angle. Now, how in the world do we turn those two numbers into an actual height? Well, this is where a little bit of mathematical magic comes into play. It's called triangulation. Now, triangulation sounds like a complicated word, but it's really just a fancy term for a super simple idea. Basically, if you know the length of one side of a right triangle, which is your baseline, and you know one of the angles inside it, that's your viewing angle, you can figure out everything else about that triangle, including its height. See, the base of the object, and the top of the object, you've just created a giant, invisible right triangle. Okay, let's walk through a quick example just to make this crystal clear. Let's say your baseline, the distance to that tree was 15 feet,
And when you look through your astrolabe, that little string landed on a viewing angle of 30 degrees.
Okay, now for the really brilliant part. You don't even need a calculator. Grab a piece of graph paper. On the bottom line, the horizontal one, make a dot at your baseline, so 15 feet in our example. Now, take your paper astrolabe and place its corner right on that dot. Find your 30-degree angle on the astrolabe and make another little dot on the graph paper. All you have to do now is draw a straight line that connects those two dots all the way to the vertical line on the left. Wherever that line hits the vertical axis, bam, that's the height of your object. It's like a visual calculator. So cool.
Of course, for all you math lovers out there, yes, there is an equation for this. You just take the tangent of your viewing angle and multiply it by your baseline distance, and that'll give you the height. But come on, that graphical method is just so elegant, isn't it?
So, think about what you've just done. You built a tool from scratch, you went outside and took measurements, and you calculated the height of something in your own neighborhood. But what you've really done is so much more than that. You've just connected yourself to this deep, powerful scientific legacy.
I mean, just think about it for a second. Ancient astronomers, they used their astrolabes to map the stars and navigate the entire globe. You used yours to measure a tree. On the surface, that seems worlds apart, right? But it's not. You both relied on the exact same fundamental principle, using simple angles and some basic geometry to understand and measure the world around you. You are both explorers.
So here's the big takeaway, the most important point. With that simple tool made of paper and string, you just use the very same principle that astronomers and navigators have relied on for centuries to make sense of the world and the cosmos. From measuring a flagpole in your yard to measuring the height of the northern lights, the science is exactly the same. It just shows you the incredible power of a simple idea.
So right now, you're holding a piece of scientific history in your hands. It's a tool that connects you to literally thousands of years of human discovery. So really, the only question left is, what are you going to measure first?